Hello everyone, welcome to VLSI Academy. This is 28th lecture and this is a second part video of timing across clock domains. Alright, let's get started. In the previous video, we saw slow to fast clock domain analysis for multi-cycle setup and hold. We drew the waveform and took the example. The link of the previous video is given in the description below. It is a small 10 minutes video only. You can please go and watch the video if you have not. In this lecture, we are going to understand the timing analysis for fast to slow clock domain. That means what will happen if your data goes from the faster domain to the slower domain. So here you can see that divided by 4 is in the capture clock path. So launch clock path is actually 4 times faster. Let us see the waveform for such kind of case. The waveform will look like something like this. So this is your launch clock waveform and this is your capture clock waveform. Now clearly you can see that launch clock waveform is faster, which means that whatever the data is launched at this edge, it will be captured at this edge, and the same data will again be launched at this edge and this edge and this edge also. So there are 4 setup edges and capture edge is 1. Why? Because we are having a launch clock 4 times faster. So that means it will launch the data 4 times. And this fourth edge, this edge is actually the most restrictive edge compared to other 3. So the setup will be checked by default with respect to this edge. Now let us consider that the clock period is 20. So 10 nanosecond is your half cycle and 20 nanosecond is your full cycle. So at every 5 nanosecond you are launching the data. This will be your 0th edge, this will be your 5th, this is your 10 and this is your 15. And the data launched at 15 nanosecond will be your most restrictive data, and by default we are saying it will check the data at this edge. It will check the data with respect to this edge. So this becomes your default launch edge. This is your default launch edge. And by default hold will be checked at previous rising edge of the capture, that is this edge. So this is your default hold edge. Now let us assume that your clock source name is CLKP and you have a divide by 4 logic, after which your clock becomes 4 times slower, that is capture clock path. So the name of that clock is, let's say now generated clock is CLKM. And now you can see that there is only 5 nanoseconds of data margin available with respect to setup check, because by default it will check for this edge. So if you want to make it as a multi-cycle path of 2, that will give it more 5 nanoseconds extra if you make it multi-cycle path of 2. Why? Because now what tool will do is it will try to match with respect to this 0th launch, it will try to give multi-cycle path of 2. So if you do that, what will happen is tool will move the setup edge 2 cycles forward. So that will be this edge now. So your multi-cycle path of 2 comes at this edge. This will give multi-cycle path of 2. That's all for this video. Please like, share and subscribe to the channel. Please don't forget to give your feedback in the comment section. Thank you.